So I'm particularly interested in what I call the pink virus. And I became aware of this in 2007. It was in February, and I was talking with one of my colleagues who had gone to an update of the San Antonio Breast Conference. That's the premier breast conference. I wasn't able to attend the San Antonio conference, nor the update in New York, and my colleague Ken had attended it, and he said, "Would you like the handout?" And I said, "Oh, but of course, yes." So took the handout home and started to pour through it. He didn't mention that there was anything particularly interesting in there. And I came across these two slides. A human mammary tumor virus linked with human breast cancers. And I was shocked, nothing less than shocked. I consider myself to be something of an expert. I've been studying this for 15 years. I've done a fellowship. I have all the textbooks. I go to the conferences. I read the handouts. I listen to the discs in my car and the tapes. I'd never heard of a virus, never. So I was very surprised. And I beat a path to my medical librarian, Arlene, and I said, "Can you find out, please, about this guy, Holland? Yeah, let me see what he's published. And by the way, can you just maybe do a Medline search on human mammary tumor virus? See what you can find." Thinking that this was late-breaking news. The next 10 slides are really packed. If I submitted these to Harvard Business Review, they would fail me. So I want to apologize. Just hang on. They're very densely packed, and I just sort of have to read. It's against the law to read off of slides, but I sort of have to read off of the slides to really convey to you this story. But think of it as kind of a CSI detective story. Arlene gave me 63 articles to read, and this is what I discovered. This virus was discovered in 1936, 70 years before I first discovered it, by John Bittner. And he was in a lab in Minnesota, and he had a strain of mice with a very high incidence of breast cancer. And he was playing around, and he noticed that mice with a low incidence of breast cancer, when they breastfed from the high-risk mice, they got breast cancer. So he postulated that this was an infectious agent, that it was something that was being shed in the breast milk of the high-risk mice that was giving the low-risk mice breast cancer, an infectious agent, 1936. He called it the milk agent. In the 1940s, more tests were done, a few more people got involved in this, and I noticed that the mice from the high-risk group, if they were fed breast milk from the low-risk group, their incidence of breast cancer went down. The low-risk mice, if they breastfed from the high-risk group, their incidence of breast cancer went from 1% to 2% to 41%. In the 1940s, he was able to determine that his milk agent was a virus. And so he sort of created this concoction. He distilled it and condensed it, and he fed it and injected it into rabbits to see what would happen. The rabbits did not develop any mammary tumors. He took the blood from the rabbits, and he put it in a test tube with the breast cancer cells from the mice, and those cells stopped growing. So the rabbits were able to develop an immunity to this virus. In the 1950s, the breast milk from the high-risk mice, if it were irradiated, it would create more tumors than non-irradiated milk. This is very interesting because I can remember back in the 1980s, there was a friend of mine who was like this health food nut, and she said they're going to irradiate the food to, like disinfect it or preserve it. And she said, they tell us there's nothing wrong with irradiating food. She said, I'm not eating it. It's interesting. I don't know if they still irradiate milk. Does anybody know? Do they irradiate milk? No? Good. Okay, here we are in the 1960s. It was discovered that human breast milk contains reverse transcriptase, the hallmark of the presence of a retrovirus. Particles similar to MMTV, this is the mouse memory tumor virus, are found in human breast milk. This is 1960s. They also found that MMTV was able to accelerate DNA synthesis. and thinking about, well, what does this virus do? How does it do what it does? Accelerates DNA synthesis. In the 1970s, human breast milk was found to contain RNA similar to the RNA found in mammary tumor virus. And in the 1970s, so we're now 30 years ago at least, right? One of the researchers said this provides compelling evidence for the relationship between a virus and breast cancer. They looked at tissue specimens from women with breast cancer, and they found that 39% of the specimens showed positivity for this virus, MMTV. Negative reactions in benign breast specimens. In the 1980s, 20% of all human milk specimens showed MMTV. 18% of women who had breast cancer showed positive evidence of MMTV in their blood. 2.8% of healthy women showed this. 35% of breast cyst fluid had evidence of this virus. Genetic sequences related to MMTV were detected in human DNA. Now, still, this has not made it into any of the conventional orthodox literature. Insertional mutagenesis was postulated as the model. Well, what is that? It means when the proviral DNA randomly takes a seat at the table, occasionally it can sit next to a proto-oncogene. Its presence, its geographic presence, will transform the proto-oncogene to an oncogene. That's what is referred to as insertional mutagenesis. This is the hypothetical model for how this virus causes breast cancer. Many more MMTV-related sequences in human DNA than previously suggested. And again, these retroviral agents suspected of being related to human breast cancer. And oh, by the way, hormones, either endogenous or exogenous, increase the proliferation of the breast cells. They increase replication of the genome. And if the genome contains proviral DNA, as the genome is being copied, more viral particles are being copied, so more viral particles are being created, and more viral particles are being created that can then implant into the genome, so the viral genome footprint enlarges. 97% of patients studied had blood cells that possessed reverse transcriptase, strongly suggesting that a retrovirus was implicated in breast cancer. The expression of MMTV, hormonally regulated. Proviral sequences are stimulated by estradiol and progesterone. 1990s. Hormonally stimulated MMTV increases the number of virally infected cells, as I've suggested. Then, of course, you can get the situation where you've got endogenous retrovirus bumping into exogenous retrovirus, and you get recombination. And if you're interested, I can tell you a story of my experience in Kuwait, which sort of had me drill down right to that one sentence there. This researcher said a substantial portion of human breast cancer is associated with viral sequences and used the term, for the first time, human mammary tumor virus. This is in the 1990s. Transmitted by milk. Now, I finished my fellowship in 1995, and I never heard a word about it. It wasn't in any of the textbooks, not even in the breast cancer textbooks, not in the conversation whatsoever. So after 2000, where are we? Well, they're turning up the volume. The researchers are turning up the volume in what they're willing to actually put in print here. We propose that humans acquire MMTV from mice. HMTV could be a target for vaccine development and breast cancer therapy. Yeah, I would think so. Considerable evidence, direct and indirect, points to a viral etiology for a portion of breast cancer. And estrogen and progesterone obviously can be considered, in our hypothesis, cofactors in this murder mystery.